A Chinese EV factory is now producing at a scale big enough to move car prices around the world. Picture that factory from above. Stamped body panels are moving through the line by the thousands. Battery packs arrive from inside the same corporate system. Electric motors, power electronics, seats, screens, and software are not scattered across a dozen distant companies waiting on purchase orders. They are being pulled into one production machine. Then the finished cars roll out. Not one or two display models for the cameras. Entire rows of electric sedans, small city cars, family crossovers, and plug-in hybrids move toward transport trucks and export lots. This is not just a cheap car story, it is a volume story. Detroit built power through scale. Toyota built power through scale. Tesla proved electric cars could be scaled too. Now BYD and China's EV industry are applying that old industrial rule to battery cars at a speed legacy automakers are struggling to match.
The headline is not that China can build EVs. Everyone knows that now. The bigger issue is what happens to car prices when one production system becomes large enough to set the comparison for everyone else. For decades, the car price system looked harder to break than it really was. Legacy automakers had brand reputation. They had dealer networks. They had engine complexity, long product cycles, financing arms, parts channels, and a century of customer habit. If a truck, SUV, or electric crossover cost close to $50,000 in the United States, many buyers were told that was just the price of modern transportation. The vehicle had become bigger, the screens had become larger, safety systems, cameras, software, sensors, heavier structures, and battery packs all added cost. 7-year loans made the monthly payment look less painful, but the sticker price kept climbing. Then Chinese EV factories went after the cost underneath the sticker.
Scale changes everything inside a car. It changes the price of battery cells. It changes the price of motors, seats, displays, steel, wiring, software, shipping, and factory tools. It changes how suppliers negotiate, because the buyer is no longer asking for parts for a few thousand vehicles. It is asking for parts for millions. Think about a restaurant buying ingredients for one table. That restaurant pays one kind of price. A chain buying food for 10,000 meals a night pays a very different price, and it can tell suppliers exactly how the system needs to work. That is the quiet power inside a huge EV factory. It does not only build cars, it changes the price of the parts that become cars. To see why that matters, start with the constraint that made electric vehicles expensive in the first place. The EV era began with a problem hiding under the floor. The battery pack was the most expensive part of the vehicle. Early electric cars carried large packs, expensive cells, uncertain supply chains, and small production runs. That made them feel like premium technology before they ever reached the showroom. A gasoline car could rely on decades of engine factories, transmission plants, supplier networks, and repair knowledge. An electric car needed a battery system, thermal management, high-voltage electronics, motor control, charging software, and a new kind of vehicle architecture. For many Western automakers, the first answer was to adapt what they already had. That made sense. It was also expensive. A legacy company could take an existing plant, modify it for electric production, build a new platform, sign battery supply deals, and price the final vehicle high enough to protect margins. Demand was uncertain. Charging networks were uneven. Dealers needed training. Regulators were pushing one direction, while buyers moved at different speeds.
So many early EVs were sold like advanced gadgets with wheels. Impressive, yes. Cheap, no. China took a different path because the pressure inside its market was different. Government policy supported new energy vehicles. City buyers wanted lower running costs. Urban charging expanded. Domestic brands fought each other with a level of speed and price aggression that would have shocked older automakers. Instead of treating the electric car as a luxury transition product, Chinese manufacturers were pushed toward volume. BYD is the clearest case because BYD did not begin as a traditional automaker trying to learn batteries. It began with batteries. The company was founded in 1995 as a rechargeable battery maker. Long before many car buyers in the United States knew the name, BYD was building expertise in battery chemistry,
battery manufacturing, and the industrial discipline of making high-volume components at low cost.
In 2008, Berkshire Hathaway took a major stake in BYD through its investment arm, which gave the company a credibility anchor outside China. That investment did not make BYD successful by itself, but it signaled that serious investors saw something different in the company. BYD moved into cars, then built its vehicle strategy around the battery as the center of the machine. That is a different starting point from bolting an expensive battery into a vehicle designed around an engine tunnel, fuel tank, radiator, exhaust system, and multi-speed transmission. When BYD launched its Blade battery in 2020, the point was not only range, it was safety, packaging, chemistry, and cost. The battery became part of the company's industrial identity. By 2024, BYD reported more than 4 million new energy vehicle sales in a single year. That includes battery electric vehicles and plug-in hybrids. China's auto market, tracked by the China Association of Automobile Manufacturers, had already become the largest pressure chamber for EV production on Earth. The answer was not one miracle robot arm on a factory floor. It was a different decision about what an automaker should control. Walk through the BYD system and the old car industry starts to look exposed in a very specific way. A traditional automaker often buys major components from separate suppliers. One company provides seats, another provides displays, another provides control units, another provides battery cells, another provides motors or inverters. Every step adds a margin, a contract, a delay, a negotiation, and a dependency. BYD's advantage is not simply that labor costs can be lower in China. That explanation is too small for what is happening. The bigger advantage is that BYD makes or tightly controls many of the expensive pieces inside the vehicle.
It is closer to building a house while owning the lumber mill, the window company, the electrical contractor, and the delivery trucks. That does not make the house free. It does not remove every bottleneck, but it gives the builder far more control over timing, cost, design, and repetition. If the windows need to change, the answer is not a year of supplier conflict. If the wiring layout needs to shift, the people making the electronics are inside the same industrial conversation. In an EV, that matters because the expensive systems are tightly connected. The battery affects the floor affects the cabin affects the wiring affects software. The software affects motor control, charging, thermal management, and driver information. A small change in one system can create a cost or timing problem across the whole car. When a company controls more of the stack, it can simplify those connections. The Blade battery shows how this works.
It uses lithium iron phosphate chemistry, usually called LFP.
In plain terms, LFP batteries use iron and phosphate instead of relying on nickel and cobalt, like many older high-energy chemistries. Nickel and cobalt can raise cost and expose a company to difficult supply chains. Iron is more abundant and cheaper. The trade-off is that LFP cells traditionally carried less energy for a given weight than some nickel-rich chemistries. So the engineering problem becomes packaging. How do you arrange the cells so the pack is safer, cheaper, and efficient enough for real vehicles? BYD's Blade battery uses long, thin cells arranged in a structure that can support the pack more efficiently. The name comes from the shape. Instead of thinking of the battery as a box filled with small, separate modules, think of it like stacking long floorboards across a room. The boards carry structure and store energy at the same time.
That matters because removing unnecessary packaging can cut wasted space and material.
The Blade battery also became known for safety demonstrations, including nail penetration tests that BYD used to show thermal stability. The practical message was simple. An EV battery could be safer, cheaper, and easier to scale if the chemistry and structure were designed together. This is where the factory story gets bigger than one battery. BYD also works across electric motors, power electronics, vehicle control systems, displays, seats, and final assembly. It can spread knowledge from one model into another. A small hatchback, compact crossover, plug-in sedan, and family SUV may not share every part, but they can share enough logic, suppliers, cells, modules, controllers, and manufacturing practice to push cost down. That is difficult for an automaker that treats the EV as one product line beside gasoline trucks, diesel vans, hybrid sedans, and old factory commitments. A combustion vehicle is built around thousands of parts that solve mechanical problems: fuel injection, exhaust treatment, gear shifting, oil systems, cooling systems, and engine vibration. An EV removes many of those parts, but it creates a new challenge. The expensive pieces are electrical, chemical, and software-driven. If those pieces are bought from outside at low volume, the EV stays expensive. If those pieces are controlled inside a massive production system, every repeated vehicle teaches the company where to remove cost. That is why the factory matters. Controlling the parts only matters if the factory can turn that control into volume. And that is where the scale starts to pressure everyone else. Volume is not just a big number in an annual report. It is a machine that teaches itself. Every time a factory builds the same part again, workers see where time is wasted. Engineers see which fasteners are awkward. Robots reveal which welds take too long. Quality teams discover which supplier batch creates failures. Software teams learn which update reduces warranty problems. Purchasing teams learn which component can be standardized across more models. This is called a learning curve, but the plain version is easier. If you build one backyard deck, you make beginner mistakes. If you build 10,000 decks, the tape measure, the saw, the lumber order, the screws, and the delivery schedule all change. Car factories work the same way, only with far more money at stake. BYD has used families of vehicles to spread the same cost logic across different buyers. The Dolphin became a global compact EV name. The Atto 3, known in China as the Yuan Plus, gave BYD a practical crossover export product. The Seal pushed into sedan territory. The Seagull, sold in some markets as the Dolphin Mini, became the small car-proof object that made Western executives uncomfortable. The Qin and Song families helped drive huge plug-in hybrid volume in China. Those names matter because they show the factory is not depending on one luxury model. A single premium EV can absorb high costs because the buyer expects a high price. A mass market system has to make the battery, motor, screen, body, and interior work at scale across many price points. The same design discipline that makes a $20,000 or $30,000 car possible also helps a company attack higher segments. Tesla is the closest Western comparison because Tesla built its power around dedicated EV factories, battery supply, software, and volume learning. It understood before most legacy automakers that an electric car company had to think like a manufacturer and a software company at the same time. But China adds another pressure. Tesla does not face in the same way everywhere else. Brutal domestic competition. In China, BYD, Tesla China, Geely, SAIC, Chery, Leap Motor, NIO, XPeng, Li Auto, and others fight in a market where price changes can come fast. Discounts, refreshed models, new battery options, and software improvements can move through the market with punishing speed. A vehicle that looked competitive 6 months ago can suddenly look overpriced. That forces factories to keep finding cost. Legacy Western automakers face a more complicated burden. Ford and GM have profitable combustion trucks and SUVs to protect. Toyota has an enormous hybrid business and a global production system built over decades. Volkswagen has European factories, labor structures, platform complexity, and brand layers. Many companies also depend on dealers who are used to service revenue, financing products, and price discipline. That does not mean legacy companies are helpless. They have engineering depth, safety experience, brand trust, and global service networks. But their cost base is harder to turn. A company cannot instantly become vertically integrated because it wants lower prices. It cannot summon battery chemistry knowledge from a press release. It cannot rebuild factories, renegotiate labor footprints, redesign platforms, replace suppliers, train dealers, and reset customer expectations overnight. BYD's scale creates pressure. because it combines two forces that are usually separate: low-cost manufacturing discipline and massive EV-specific volume. In China, that pressure has already shown up in price cuts. BYD has reduced prices across multiple models during domestic price battles. Tesla has adjusted prices in China repeatedly as competition tightened. The point is not that every cut is permanent or painless. The point is that Chinese buyers now see EV prices move like consumer electronics prices. That is a serious shift. For years, car buyers were trained to expect advanced technology to cost more. The larger screen costs more. The more advanced powertrain costs more. The electric version costs more. The long-range version costs more.
The new safety package costs more. China's EV price war attacks that instinct. It says a more digital, more electric car can get cheaper when the factory is large enough, the components are repeated enough, and the competition is harsh enough. Once that volume leaves the factory gate, the proof stops being theoretical. It shows up in export lots, shipping ports, dealer price sheets, and anxious meetings inside older automakers. China is no longer only the world's largest car market. It has become one of the world's largest vehicle exporters. According to industry reporting from the China Association of Automobile Manufacturers, China exported more than 5.8 million vehicles in 2024, including more than 1.2 million new energy vehicles. Those numbers are not small background statistics. They mean Chinese production is spilling into global price comparisons. Chinese EVs and plug-in hybrids are already visible across Europe, Southeast Asia, Latin America, the Middle East, Australia, and other markets. In Thailand, Chinese brands have pushed hard into the EV space. In Brazil and Mexico, buyers are seeing Chinese vehicles challenge old price expectations. In Europe, tariffs and investigations have become part of the story because the price gap became too visible to ignore. Even where direct entry is blocked, the pressure leaks through. The United States is the clearest example. Americans do not see BYD cars on every street corner because tariffs, policy barriers, and political scrutiny make the market difficult. But Ford, GM, Tesla, Hyundai, Toyota, Volkswagen, and Stellantis still operate in a world where Chinese EV prices are known. They can keep BYD out of a specific showroom, they cannot keep the comparison out of the industry. That comparison becomes especially sharp with small cars. The BYD Seagull is the proof object. In China, it has been priced at levels that make many Western low-cost EV plans look uncomfortable. Sold in some export markets as the Dolphin Mini, it is not trying to be a luxury statement. It is a small electric car built around the question that scares the industry. How much EV does a normal household actually need, and how cheaply can it be built? A small car like that does not have to conquer the United States to affect the global market. If it sells in Latin America, Southeast Asia, or parts of Europe, it forces rivals to answer the same question. Why does our small EV cost so much more? That question has consequences all the way up the chain. Suppliers are pushed to reduce component prices. Local automakers demand cheaper battery packs. Governments ask why domestic factories cannot match the cost. Consumers start comparing range, warranty, screen size, safety equipment, and monthly payment instead of simply comparing badges. BYD has also moved beyond exporting from China. The company has pursued or announced manufacturing and assembly footprints in places such as Thailand, Brazil, and Hungary, with other international plans reported in different markets. The reason is straightforward. A Chinese EV company that builds closer to buyers can reduce shipping exposure, deal with tariffs more directly, and present itself less as an outsider shipping from one giant home base. But the origin of the pressure still sits inside the Chinese production system. A car assembled in another country can still depend on battery know-how, platform design, component purchasing, and factory discipline developed in China. The global plant becomes an extension of the original industrial machine. That is why the largest consequence is not one cheap car.
It is what happens when the global car industry has to price against a Chinese factory system instead of one Chinese brand. A massive, vertically integrated EV factory can move global prices in 4 connected ways.
The first is the visible benchmark. When buyers see an electric car with acceptable range, modern screens, safety equipment, and a usable warranty at a much lower price, the old price ladder weakens. The entry-level EV no longer has to be imagined as an expensive compliance product. It can be a normal car. The second is forced discounting. If a Chinese model undercuts a rival by thousands of dollars in Europe, Thailand, Brazil, Mexico, or Australia, that rival has to respond. It can discount, it can add equipment, it can offer better financing, it can change the warranty, or it can watch buyers walk across the street. The third is supplier pressure. Once Chinese factories prove that batteries, motors, inverters, displays, and electronic controls can be produced at lower cost, suppliers elsewhere face new expectations. A Western automaker can turn to its battery partner and ask a harder question. If China can hit that price, why can't we? The fourth is government response. Tariffs, subsidies, local content rules, industrial policy, and investigations all become part of the price. When governments impose barriers, they may protect local factories for a time, but they also admit that the underlying cost challenge is real. That is why this story matters even for an American buyer who never sets foot in a BYD dealership. The United States can use tariffs. It can use tax credit rules. It can question data security, software trust, and supply chains. Those issues are real. But Ford, GM, Tesla, Hyundai, Toyota, and Volkswagen still have to prove that their electric vehicles are worth the difference in price. That proof used to be easier. A legacy badge carried safety, service, resale value, and familiarity. For many buyers, that still matters. A family buying a vehicle in Ohio, Texas, or Pennsylvania wants parts, service, financing, crash confidence, and a dealership that answers the phone. A lower sticker price does not erase those concerns. That is the balanced part of the story. Chinese EVs face serious barriers outside China. Tariffs can reshape the final price. Safety certification takes time. Software trust matters when a vehicle has cameras, connected systems, and over-the-air updates. Dealer and service networks are expensive to build. Brand perception does not change overnight. National security scrutiny is not going away. A factory does not automatically win every market just because it produces at scale. But it changes the comparison. Before, the question was whether Chinese EVs could match Western and Japanese automakers on quality, range, safety, and desirability. That question still matters, but a second question has arrived beside it. If a Chinese factory system can build a usable electric car for thousands less, why is everyone else so expensive? That question is uncomfortable because it moves from engineering into household economics. A buyer does not live inside a corporate strategy deck. A buyer sees a payment. A buyer sees insurance. A buyer sees charging cost, fuel cost, warranty, resale risk, and the price of replacing an old car. If one automaker can make the monthly payment lower without making the car feel cheap, the rest of the market has to react. That brings the story back to the opening image. Not a factory as a building, a factory as a price-setting machine. The finished EVs leaving the gate in waves are not just vehicles, they are arguments on wheels. Each one says the old assumption may be wrong. For years, the industry told buyers that advanced cars had to become more expensive as they became more electric, more digital, and more complex. The battery made the car expensive. The software made the car expensive. The screen, sensors, motor controls, and safety systems made the car expensive. The future came with a higher payment. China's factory model challenges that from the opposite direction. It treats the EV less like a luxury technology and more like mass-produced consumer electronics on wheels.
The first unit is hard. The millionth unit is cheaper. The battery chemistry gets standardized. The platform gets repeated. The supplier network gets squeezed. The software gets reused. The factory learns. That does not mean every Chinese EV is better than every Western car. It does not mean the lowest price is always the best choice. It does not mean Toyota, Tesla, Ford, GM, Hyundai, Volkswagen or Mercedes suddenly forgot how to build cars. The sharper point is that the pricing floor has moved. BYD's vertical integration, LFP batteries, repeated platforms, domestic price wars, export growth, and overseas factory plans all point in the same direction. Once one system proves a lower price is possible, every other automaker has to explain why its car costs more. That explanation may still be good. It may be safety. It may be service.
It may be brand trust, software confidence, performance, towing ability, resale value, or local manufacturing. But the explanation now has to be made. The old industry cannot just point to the battery and say the car must be expensive. The factory has answered back. And that is why a Chinese EV production system can move car prices worldwide without parking a car in every American driveway. It changes the reference price in the minds of companies, governments, suppliers, and buyers. It tells the global market that the electric car does not have to remain a premium object forever. Maybe this is a temporary price war. Maybe some companies lose money. Maybe tariffs slow the effect in certain countries. But the question has already changed. The debate is no longer whether China can build electric cars at scale. The debate is whether the rest of the world can build them cheaply enough to compete. That is the real threat inside the factory image. Stamped panels moving by the thousands, battery packs arriving from the same industrial ecosystem, finished cars rolling toward export lots, and price assumptions leaving with them. One Chinese EV factory system is not just producing cars, it is changing the price conversation around cars. If this kind of proof-led breakdown is useful, like the video, subscribe, and turn on notifications for more reports on the machines, companies, and production systems shifting the future before most people notice. Here is the practical question. If a Chinese EV delivered the same range, safety, warranty, and daily usability for thousands less, would you buy it? Or would you still pay more for a familiar legacy badge? And at the market level, is this only a temporary Chinese price war? Or has the global car industry crossed into a permanently lower-cost EV era?